everybody. Good morning and welcome to our today's webinar, Connecting Architects and Engineers, Automated Model Import with a FRILO BIM-Connector. My name is Victoria Rakowska. I'm responsible for international sales and partner management at FRILO Software GmbH in Stuttgart. Here with me is also my colleague Tamara Schäfer, and she will take care of your questions. If you would like to put any questions during the webinar, you can use the section. In your webinar, go to webinar control panel. There are two sections, in fact. One is the questions section and the other one is the chat. You can use any of those to put your questions during the webinar. If we don't answer them instantly, immediately, we will for sure get back to you after the webinar, and there will be no question left unanswered. Okay, first of all, I would like to describe the background, why we have decided to develop and to launch the FRILO BIM-Connector. And yeah, there is always a large number of participants involved into the construction process. These are architects, engineers, building contractors, and many others. And as a software manufacturer, we constantly analyze the way our customers, that are structural engineers, work and try to extend the FRILO functionality accordingly to satisfy the needs of our customers, of the structural engineers. And yeah, we know, and you know, if you are a structural engineer, accidentally, that we are facing a lot of challenges in the everyday work, in the projects, because there is always a time pressure, there is always a big workload, and it is difficult to concentrate on the actual tasks that is structural analysis and design. And we asked our engineers which tools would be helpful in their daily work routine, which would bring them one step further and let them work more efficiently. And most of them answered that fast entry of the building components into the FRILO calculation programs would help them a lot. This is how the FRILO BIM-Connector was born. So what happens? What does the BIM-Connector do? Thanks to this functionality, our customers can minimize the effort of the geometry transfer into FRILO structural analysis programs. It literally replaces the manual data entry with an automated model import via IFC or SAF file, but you can transfer it within the FRILO application environment if you have an IFC or SAF model from your architect or maybe from the other 3D structural analysis program. Among the main benefits, it is worth to mention, first of all, considerable time saving and workflow optimization. You don't need that long hours to enter all of the measurements, all of the geometry of your model manually. Then you have faster communication between project participants. Of course, the quality improvement and avoidance of manual transmission errors if you are transmitting the model like manually or semi-manually. And you can respond to the changes fast. And as a result, you can stronger focus on your actual work, which is structural analysis and design. So how does it work? The BIM-Connector is in principle an entry point for the physical and analytical building models that are coming from architects or 3D engineering solutions into the FRILO application environment. And as I already told you, it supports IFC and SAF file formats. Maybe I will tell you a few words about those two file formats. The first one is IFC. It's the industry foundation classes. It is an object-based file format with a data model developed by Building Smart Alliance to facilitate the interoperability in the AEC, which is architecture, engineering and construction industry. And it is a collaboration format which is commonly used in the building information modeling based project. The model specification is open and it is available to everybody, and it is currently very widely used in the 3D CAD solutions, in the 3D CAD solutions. The other model type is the structural analysis format, SAF. And in this format, we are getting the analytical models from the architects or other engineering solutions. It is an Excel-based open source format developed and optimized especially for storing and sharing structural analytical model data between modelers and analysis software. So after we have one of those models, we can very easily import it into the BIM connector, FRILO BIM-Connector. And if it is an IFC file, first we need to convert it into an analytical model, because IFC files, they contain physical models. So in case of IFC, we convert it in the BIM connector. In case of SAF model, we don't need to convert it. We just can do a certain adjustments and then easily move the model forward to the FRILO application environment. And in case of the adjustments that have to be done with the IFC format, there are a lot of tools, a lot of useful functionalities that you will find in the FRILO BIM-Connector to make those adjustments happen very fast so that your model is structural analysis ready and can be handed over to the FRILO calculation programs. Okay, so which FRILO calculation programs are connected right now? At the moment, you can pick up either one slab from your model in the FRILO BIM-Connector and hand it over to the slabs by finite elements PLT program of FRILO. Another possibility is to select an individual reinforced concrete column and then hand it over to the B5, which is reinforced concrete column program of FRILO. And the last one and the most comprehensive possibility is to select the entire model. In fact, you don't need to select it even. You just press the button export, which you will see shortly in the demo, in a video that I brought for you, and just export the entire building model from the FRILO BIM-Connector into the FRILO building model program, which is called GEO building model. And in this program, you can distribute vertical loads. You can, of course, also apply some external loads like wind loads or snow loads, maybe earthquake loads, and then this building program allows you to distribute them vertically to the individual building components. And after that, in the next step, the building components with the assigned individual loads can be handed over to the FRILO individual calculation programs for the element design. So this building model, in fact, opens you the door to the entire FRILO application environment. Okay, now we have come to the point where I will show you a short video how you can work with FRILO BIM-Connector and an IFC file that, in this case, we are getting from an Archicad architect, so the architect that is using the Archicad solution of Graphisoft. So let's start and see how it works. I'm starting the FRILO BIM-Connector. It is in my favorites in the FRILO application environment. And as you can see, first I have some first steps described, how I can prepare my IFC file so that it can be imported in the best way. Then I select the file itself and open it in the FRILO BIM-Connector. And now we are landed in the physical model view. As you can see, the models coming from architects are mostly having this top-down structure, which is not common for the structural analysis and design. This is why first I have to reassign the floors in a way that we have a bottom-up structure, the one that is also relevant for the structural analysis. It is very easy to do it with the help of the floor allocation function. And I can, like floor by floor, convert my building into the bottom-up view. As a next step, we can assign the material quality. As you can see, the materials themselves are already there. This gray material is the reinforced concrete, and the red one is the masonry. They have been taken out of the IFC file from our architect, but we still need to add the material quality. This can be also done with the help of this specification function in the top menu bar, where you can select the individual material quality for each material used in our building. For example, masonry quality and reinforced concrete quality in our case. What can we do as next? We can remove the non-load bearing components from our building automatically also. This is with the help of the load transfer via material button. The small thicknesses as well as the names of the components that contain certain words, they are analyzed, and in this way, maybe I will stop for a while just to explain to you. In this way, for example, the isolation layer can be filtered out automatically because it has the word isolation in the name, or Dämmung in German case, as you saw on the video. So all both English and the German words are wording is supported in the program. Another way to find those non-load bearing components is to analyze the thicknesses, and it is built into the functionality of the program, and based on those thicknesses of the elements, as you can see, most of them, of the non-load bearing elements, have already been converted into this transparent view, which means that they will not be considered while converting the entire model, physical model, into analytical model. And if some of them have been overlooked with this automated functionality, we can still convert them into non-load bearing manually, as I do it here in the video. Yeah. Okay, now we can switch to the analytical model. That means if I switch the step on the top, I'm converting the entire model into the analytical model. The non-load bearing components have disappeared, but if I go back to the physical view, I will see them again. And we can see that the components are not connected yet because they are reduced to their mid-surfaces and axes in case of columns or beams. And of course, they are not on the same level if you are converting just a physical model to an analytical model. But before I join the components, I can also see here some small openings, corbels, notches that don't belong to a structural model, to the analytical model. And I would like to clean up the geometry via entering the respective dimensions here, so that the small wall and columns and beam and column sections and slabs, they will be just automatically removed from the entire model. You see, there are a lot of such situations in my current model, and they are displayed now in the long list in this table. I can Control A and mark all of them, let them get them displayed on the screen, and then clean them up automatically at all places where they have been identified. Okay, now after I have cleaned up my geometry, I can see that there is the need to join the elements, of course. So we will join them automatically first. And as you see, the walls are already matching to each other, and also beams and columns. But there are certain areas where they have not been connected yet. And this can be done manually in the next step. Maybe why they have not been connected, that's also, I can make a short comment to that. There are certain preset distances between the building components that are considered while connecting or joining the components automatically. And if the distance is too large, then it cannot happen automatically, and we still need to control those areas and to join them manually. Of course, it's also easily done with the help of this join manually function. Okay. So I have to repeat it in all of the sections where the column is not connected with the beams and the beams are not joined. So I am marking the first elements and then the second elements, which will be extended to the first one selected. Okay. Good. So one more left. So first marking the beams, then the column, and extend the column to the beams. Very well. Now we can see that the model looks very good. We still need to connect the two slabs in the bottom because the geo building model, like the program where we would like to hand over everything, it supports only one slab per floor. So it has been connected now, or is being connected. Exactly. And what I need to do before I transfer it, I need to make the final model check. It is checking the eggshell positioning of the members, if they are positioned exactly over each other, the middle axis and the middle surfaces of the walls. And to run this check, it's important because sometimes the materials have different thicknesses, and you will see right now we have such a situation here. If the wall has a different thickness than a beam which is laying under the wall, if we reduce them to the middle surfaces, of course they will not be completely 100% over each other. So you see here in the analytical model view, but we will jump in the video also shortly to the physical model view to show you the situation where you can see it better in the physical model view, that the wall is literally like thinner than a beam, and this is why in the middle surfaces and axes are not correctly positioned. Yeah, it happens in all of the 4 sides of our building that we can follow in this table of all of the situations where the actual position is not correct. Okay. What can we do in this situation? Yeah, we can move members manually. I decided to move the walls to the beams. So I first mark the walls, then the beam, and then use this function move members on the top of in the top menu bar. I have to repeat it in all 4 sides of the building. Select the wall. And after that, you see I need to join automatically again, because if I move the axis, again, I need to join the members in this connection parts. The other useful function is to disassemble the walls or to split them into stripes and to consider the openings in structural analysis and calculation. There are 2 possibilities, either just in stripes, or you can convert the lentils into the beams, which I have done in this video. So you see they have been converted, like the lentils above the openings, into the beams. And now I can export the entire building into the FRILO building model program. I just selected export and pressed export to building model, and I will control my building in the 3D view first. If everything has been transferred correctly, we can see the opening have been considered, and we have the beams created above the openings. So it looks good, it looks correct. So we can now proceed with the building calculation. First, we have to enter the stiffness of our building in the foundation floor and in the part of the ground floor. So first, the stiffness has been entered in the foundation floor, and now we go to the second floor, and we have to select first part of the slab which is relevant for the stiffness. You can do it like via marking the entire area that is relevant for our stiffness. And after it has been done, yeah, we are just applying the stiffness to this area. Okay, now the building is ready for calculation, and we are pressing on calculator icon, which means calculate. And in this moment, the vertical loads, like the self loads that have been transferred, which can be transferred because we have the geometry, we have the materials and materials quality. And after consideration of these parameters and the stiffness, we can distribute the vertical loads in the building. And after it has been done, we have the individual loads assigned to each building component in this building. And on the left side of the screen, you see the long list of the programs that are connected to the FRILO building model, in which you can, in the next step, analyze, design, and calculate all of those individual building components, like slabs by finite elements, walls by finite elements, then masonry wall, masonry design general program. Then we have a reinforced concrete column, a single span steel column, timber column, punch and shear analysis can be done also, continuous beam, reinforced raft foundation, other foundation types, and soil settlement. So these are the programs that are currently connected to the FRILO building model. Okay, so I think I am through. Thank you very much.